Good evening. Today we'll be having a discussion on the IO system, IO organization, functions, and IO buffering. So, before we start the organization of IO functions, let us make a discussion on the IO devices. So, when you make a consideration of a computer system, the majority part of the discussion as well as implementation, the focus is majorly on two major components. That is, we are majorly focusing on the processor, and we are a lot of consideration it is being made for memory also. IO devices, they also play a very important role, because IO devices are something which are going to provide the external interfaces through which the users, they are going to make interaction with the computing system. So those two components, that is processor and memory, they are very important and they must be given due consideration. But IO devices, they also play a very vital role in the computer system. So today we'll be having a discussion on the IO devices, how the organization of IO functions, they take place, and we'll be making a discussion on IO buffering also, and also some operating system design issues we'll be having a discussion on. So to start with, when you see a computer system, you will observe that a number of IO devices, they are attached to the computer system. We can actually make a classification of these devices into a set of classes. Like, we can say the devices to be belonging to human readable category. We may be saying that the class to which the IO device it is belonging to is machine readable. Another class, it could be communication devices. So we are making this what is the basic property that which we will see in the devices, and after seeing the property, we'll be placing the devices in the classes. So three classifications I told you of IO devices, that is human readable, machine readable, and communication. So if you see a device, and this device is meant for making communication with the user, you can actually place that device with in the category that is human readable. And what are devices? You can think of a printer to be in this category. You can think of the terminals of various types, like visual display unit, you may place in this category. You can think of keyboard to be placed in this category. You can think of mouse also to be placed in this category. Now beside that, if you are seeing a device, and that is what is making communication with the electronic components that which are present in the computer system, then you may be placing that device in the second category, the second class which I specified, that is machine readable category. And you can think of a disk, and you can place a disk in the second category, that is machine readable category. Now beside that, the third category which I specified, now if you want to make a communication with a remote device, then again a set of IO devices, it could be utilized, like a modem, it could be utilized. So we'll be placing modem in the third category, that is the communication category. Now when you, these three classes I specified, in which we can actually based on the property that which the device it is placing, we will be placing the device in one of the categories. Now moving ahead, when you see a device within a class, and when you see devices in different classes, you will see that devices, they portray a different type of behavior in a lot of aspects, like in terms of data transfer rate. So when you are making a consideration of a device in terms of data transfer rate, you will see a lot of variation. Some devices they are very fast, some devices they are slow. So in terms of data transfer rate within the same class and between different classes, the devices which are placed in different classes, you will see variation. Now, now you will see differences in terms of application. Devices, they are meant to provide a set of applications. Like if I make a consideration of a device, say disk, then disk, it is meant for a particular application. We can think of disk for providing secondary storage, and also we can think of we just had discussion on virtual memory. So if you want to have a virtual memory implementation, then again disk is something which could be utilized. Now if you are making a utilization for secondary storage purpose, or if you are making a usage for virtual memory implementation, some additional frameworks, some additional support, it is going to come into picture. So that is also one aspect that will be making a consideration of when we will be seeing the different devices placed in different classes, or within the same class also you will see a variation. Now you can make even the consideration of terminals, the privileges that which are given over a terminal to the different users. The administrator, he is given a different set of privileges, as well as a normal user, he may be having a different set of privileges. Likewise, a difference will be in terms of complexity, that which is associated with the control. Now, when you are making a consideration of a printer, the, the, the code that is going to get implemented for printer, the interfaces, and it is going to be simple, lot more simple than when you are making a consideration of a disk. It requires a firmer control. It requires a lot of thing is supposed to be done when you are making a consideration of a disk. So complexity, in terms of complexity, that which is utilized to control a device, there will be variation. Now beside that, in terms of unit of transfer, unit of data transfer, again within the same class and between the classes, you will see differences. In fact, the devices, they are classified into various categories. You can think of block oriented devices, you can think of the character oriented devices. The block oriented devices, they store information in blocks, and these blocks, they are having addresses associated with them. And when you are thinking of a character oriented devices, then character oriented devices, they accept or deliver data in terms of streams of characters. So that is something that which you may see. Now you may see a difference in terms of data representation also. So there is a difference. Different devices, the way they are making a representation of the data, the formats, there is going to be a difference. Now beside that, error handling also is something. When you make a consideration of different devices, you will see a variation. Now coming on to the second part, the first part, it dealt with the basic I/O devices, the classes of I/O devices. Now what all things you will see associated with an I/O device, that is data transfer rate is going to be there, complexity in terms of control will be there, and we'll be seeing the differences between when we go from one device to another device. We will see a difference. When you are thinking of organization of functions associated with an I/O device, you are supposed to think of two major things. The first is the device itself, and the second would be how the device it is going to get interfaced with the other components. components which of the computer system. So there are two aspects when you are thinking of organization of the functions that which are associated with IO device. You have to think it in two ways. The first step would be thinking of the IO device, and the second step, which I just specified, how IO device it is interfaced with the other components of the computer system. So we'll be going a long walk is going to be there during our conversation, and during this conversation there will be a set of terms which will appear. So the first term that which appears during the discussion, those terms they will appear. So first we'll make a discussion on those terms, and then we'll proceed further. The first term that comes is bus. So what a bus is? The term bus in the context when we'll be making a discussion, bus, it is basically something that covers not only the physical links among the components, but also the mechanisms for controlling the exchange of signals over the bus. Now during our discussion and in the figures also, we'll see the figures, and in those figures we'll be seeing something that is system bus, memory bus. Memory bus, it is sometimes called system bus. So the system bus is something that handles all intra-system communication. The system bus, it comprises of three main groups of lines. So when you will be seeing system bus, you will be seeing that it comprises of three main groups of lines. So address lines are there, address bus you will see, data buses you will see, control buses you will see. Address buses or address lines, they are generally comprising of the number, it varies from 8 to 32. Generally it varies from 8 to 32, and when you are thinking of the data lines, the variation is in between 16 to 128. Control lines, they are basically meant for performing the various operations, like memory read operation, it could be there, memory write operation, it could be there, interrupt, IO interrupt, it could be there. So when I am speaking of line, I am speaking of the framework that which will be utilized to distribute electric power to the bus units, the various bus units. There has to be a mechanism via which the electric power distribution it is going to take place, and the lines which I am associating with the address, data and control specifications, they will be meant for this purpose. Now memory bus, I already told you that memory bus, system bus, sometimes system memory buses, they are also called system buses. Now when you are making a consideration of magnetic disk unit and other secondary memories, then transferring the data serially, generally these devices they transfer the data serially, therefore they need to be connected to the system bus via interface circuits that are called IO controllers. And these IO controllers, they perform serial to parallel and parallel to series format conversion and other control functions. A single IO controller can interface many IO devices to the system, and to the system bus the interfacing it could go, and the IO devices are connected to a separate bus. So this bus, it is called an IO bus. The IO units that which we will be seeing, the IO units, they are generally comprising of two parts. When you will be seeing the IO units, they basically comprises of two parts. Mechanical part is going to be there and an electronic part is also there. So electronic part, that which is present in the IO device, and which it could be a part of the main board, or there you can place it via an attachment that is there in the board, and that electronic part, it is called the device controller or the adapter. So there are a few more concepts that which we'll be having a discussion in a short while, and these are a few terms like bus is going to come, then system bus is something that which you may see over in the figures, then memory bus and system bus are one and the same thing. Then IO bus is a term which will come. Controller is something that you will see, and all in all, I believe most of the terms that which will appear, I made a brief description of them. Now coming to the, this is memory mapped IO device. So before we proceed further, now so in our previous discussion, we already saw that figure where there was processor was there, then memory management unit was there, and then memory bus figure we already saw. So like the processor, it want to make a communication with the memory. Likewise, the processor may be wanting to have communication with the various IO devices also. So how this communication is going to take place? So I already told you that a device is there, and this device, it is associated with a device controller, and there are certain things which are there in the controller. So you will be seeing control registers are there, then status registers are there, then there are a set of registers which will be serving as the input and output buffers. So IO devices, they are meant for input and output operations, and processor, whatever the operation, the processor it is eyeing with an IO device. Control registers, they are also called command registers. So what processor will do is, processor will assign will send the signal, whatever operation in the control register, things they will go, what operation the processor it want to have on the IO device, things they will appear in the control registers or the command registers. So there has to be a way via which the processor it can make a communication with the IO devices, basically the control registers, from where things they will appear, what operation is supposed to be performed. So in control register, things they will appear in that what is the operation that the processor it is intending out of the IO device. So it will appear in the control register. So there has to be some way via which this communication it could take place. So we'll be making a discussion of two approaches, that is memory mapped. The first is memory mapped IO organization and IO mapped IO organization. We'll be making a discussion on these two approaches. So in the first approach, this is the first approach, and in this approach you will see one thing. So the thing is, the instructions are there. If you see, all in all, IO data transfers, if you see all IO data transfer in memory mapped IO, all data transfers are implemented by memory referencing instructions, and there is no other way. So we are having the memory referencing instructions, although there will be instructions which will be having unique addresses. For performing IO operations, there will be instructions which will be placed in different memory sites, but the addresses are going to be the same. The memory referencing instructions are going to be something via which the IO operations they are going to take place. No separation is there. So memory sites will be there, addresses will be there, although unique addresses will be provided, but via the same framework, things they are going to be done. So this is the organization. In this organization, you will see the phenomena taking place. So these are the buses, and this is the channel. So in this channel, the IO devices are there. These IO devices, the processor, it is going to make a communication with, and the same memory bus, it is going to be utilized for performing the operation with the IO devices. So the thing is, there are three buses. You are having control bus, you are having address bus, you are having data bus, and no separation is there. So memory referencing instructions are going to be utilized for performing the memory mapped operations. Then we'll be seeing the second framework. So actually the thing is, with every IO device we are associating ports, and with every IO device control registers are there, and to the control registers we are associating ports, and these ports they are associated with addresses. So when we are making out the referencing of those control registers via the memory referencing instructions only, then no distinction is there. Then we will be saying that we are performing memory mapped IO operation. So again coming back, so I already told you that devices are there, and these devices, IO devices are there, and these devices they are having these control registers. These control registers, some ports are associated with them, and ports they are associated with addresses. So there are some computers where we employ IO instructions that are distinct from memory referencing instructions. So in case of memory mapped IO, no distinction is there. In case of IO mapped IO, there will be a distinction. Some IO instructions will be there, and those instructions they will be distinct from the memory referencing instructions, and these instructions which are different from memory referencing instructions, they produce the control signals to the IO ports. So there also IO ports are there, and to those IO ports the memory referencing instructions they are producing the control signals. Whereas in this framework, that is IO mapped IO organization, there will be some different set of IO instructions which will be producing the control signals, and the IO ports are going to make a respond of that, and these are not not the memory locations. So these instructions produce control signals to which IO ports but not memory locations respond. So when the IO instructions that which I am speaking about, when the execution it takes place, then the IO ports are something which are going to produce the response. It is not the memory locations which are making a response. So all in all, you can speak of IO mapped IO as a case where some IO instructions are there, and these IO instructions, they are distinct from the memory referencing instructions. These instructions, they produce control signals to which the IO ports, they are making a response of, and the memory locations are something not which are making a response of. Like it was in the case of memory mapped IO, the reverse was there. Here the things, they are somewhat different. Let us have a better picture of that. Now in this case, a decoder is there for memory addresses, and a decoder is there for IO device interface circuit, and IO devices are there, and so you will see two separate channels. Now these two lines are there for memory read and memory write, and these two lines are there for IO read and IO write. So the other is same. Address and data bus is same. Address and data bus is something that which is common, but control signal is something which is varying. So you may see, I was speaking of the control registers. So control registers, they are basically the command registers, and so the operations are there, and we have made a distinction. So distinction is something that which is made. So in IO mapped IO device organization, this is something that which happens. Now up to this point, we are able to cover something, that is processor. It is supposed to make communication with the IO device, how it is going to be done. So we are able to cover memory mapped IO, which is one approach, and then we are able to cover this also, that is IO mapped IO. So when you think of a program, now the second part, it speaks of now a program is there, and this program will be requiring an IO device. So how things they will go. So program instruction will be there, and communication it is there with the processor, this much done. But the later part, the next part, how things they will appear after this. So how things they will appear, there are various approaches to accomplish this. So we will be making a discussion of three approaches, that is programmed IO, interrupt driven IO, and direct memory access. So before proceeding, think of the phenomena like you are having a program. So we'll be first making a discussion on programmed IO, what programmed IO is. So in programmed IO, you will be thinking of a program, and suppose the operation is there. What the operation is, there is something which is supposed to get printed out of a printer. So there are a set of characters which are supposed to get printed out of a printer. So in programmed IO, what actually happens is the program, it goes to a busy waiting state. What a busy waiting state is? It is not a waiting state. So I'll be trying to explain the thing with these two figures. These two figures, I'll be trying to explain the phenomena. So I already told you that device controller, it is associated with a set of registers are there. So a register is there which is called a set of registers. They could be utilized to specify the status of the IO device, whether the IO device it is ready or not. So here in busy waiting, what happens is the program it goes into the busy